right, so make sure you've numbered this number 1. Make sure your name is on it. Number 1, make sure our name is on it. We're starting a new list today. It's going to take me a while to grade that stack of binder checks, but I'll get those back to you hopefully within the next 2 weeks. Today, I want to talk to y'all for just a second before we start writing down all this vocabulary. All right. Today, we're starting a new topic of algebra. This basically, we will do algebra until we get to Christmas break, okay? Algebra is very simple as long as you don't make it more complicated than it is, all right? I know that there are going to be some letters involved that we're going to see, all right? But those letters, we're going to talk about them today. It's just like regular math, all right? So I don't want you to think that algebra is something fancy. It's not. It's just regular math, okay? On the test, a lot of us have still been struggling with vocabulary. Guys, some of y'all are doing awesome. Some of y'all knocked the vocabulary out of the park, and that is fantastic. Some of us, not so much, okay? Guys, I give y'all the exact definitions that are on the test. Today, I'm going to give you all of the vocabulary that will be on your test in 2 weeks. So this Friday, we will have a quiz. There's not vocabulary on the quiz. All right, I'm thinking we might need to start adding vocabulary on the quiz. All right. Y'all's test on this material is not this Friday, but next Friday, and it will have vocabulary on it, and this is what you need to study for that. Guys, that gives you 2 weeks to know your vocabulary. Go home tonight, make some flashcards. Make sure we come in 2 weeks, and you can tell me these right off the bat if I give you a definition. Okay? All right. So let's talk about algebra real quick, because this is the word that kind of makes us go, woo, that sounds scary, that sounds hard. All right, algebra is a mathematical language of symbols, including variables, and we'll talk about what those are in a minute, and numbers. Yes, sir.
Isn't algebra like you solve for square and you solve for x?
A lot of times, yes. All right, for right now, so a lot of times, like y'all, when you think of algebra, you think that means you're finding x. All right? And while that's true, for these first 2 weeks, we will not be solving anything. If you're solving for x, that's called an equation. For these first 2 weeks, we are just going to talk about expressions, and we're going to talk about that in just a minute. Hunter?
I think, I think algebra is like let's say you did like 1 plus a, wouldn't that be like 2 since the first letter in the alphabet?
Okay, so 1 plus a. If you just say 1 plus a, right now that has no meaning, okay? A can be any number in the world. A could be 87. A could be 5,796. A could be -4. Okay? A can be anything. So if you just have 1 plus a, that will not be a math problem given to you. But yes, that's what we're thinking. Okay? All right, and we're going to talk about that in just a minute, all right? So algebra is where you have these symbols. It's a math language. Well, guys, can I ask you something real quick? Guys, we've done a lot of vocabulary in here, right? And a lot of those words have been something you haven't heard before. Wouldn't y'all agree that math just by itself is its own language? Like it's almost like learning a foreign language sometimes in here, all right? Guys, so when it says algebra is a mathematical language, it's just saying that when we're defining vocabulary words, mathematics is its own language to start with, all right? And then this is just a special branch of that, okay? So that's like English. Guys, does everyone in the whole world speak English the exact same way? No, like there is a very distinct difference in the way we speak English down here in the South and the way they speak English up in like New York, okay? There's a very big difference in the way those are spoken. There's a very big difference in the way it's spoken out in like California. Okay? Like there are some words that just don't translate. They use different words. Like we say, like a Coke for us, that could be a Pepsi, it could be a root beer, it could be anything. For them, it's a pop, okay? We don't say that. That's like if someone asks you for a pop, you'd be like a papa? I don't understand what you're saying, okay? So, a popsicle, yeah, like that might be what I think, okay? So, like again, just like in the English language, you have different areas that speak differently. In math, it's the same thing. All right? My people that speak Spanish, like, is Spanish the same everywhere? No, like it's definitely different in Mexico versus in Venezuela versus Spain. Like Spain is like doing their own thing with like vosotros and stuff like that. Like they do some weird stuff, okay? Tony?
My two different families speak like different kinds of Spanish.
Really? So you have like two different Spanishes in your own family. That's awesome. All right, I have some friends that are they're from Brazil, yeah, and they speak Portuguese, which is related to Spanish, but a completely different language in itself, all right? So real quick, guys, algebra, it's just math. That's all that's saying. It's a math language, it's math. All right, here's the difference, is it has your symbols, like adding, subtracting, and multiplying. It has your numbers, but it also has something called variables. So let's define what a variable is. A variable is a symbol, usually a letter. And it's used to represent a number. All right? So it's a symbol, usually a letter used to represent a number. Now, guys, this says usually a letter. I mean, technically, you could use like smiley faces and unicorns, all right? Now, they take a lot longer to draw out than a letter, all right? Plus, if you start writing math with smiley faces and unicorns, someone's going to think you're crazy, all right? So we're going to keep it simple. We are in 6th grade. We want our work to look as professional as a 6th grader's work can. We're going to use letters, all right? Guys, raise your hand real quick. Has anyone, raise your hand if you've ever held a spot in line for a friend. Anyone ever held a spot in line for a friend or maybe like a family member, whatever, whatever. Okay, so everyone's held a spot in line. Put your hands down. You just did the job of a variable. What's the variable holding you spot for? A number. So like when you earlier, Hunter, you said 1 plus A, right? Okay, 1 plus A. A is waiting on a number. Any number. Now guys, the way that you're going to know what number it is, either I'm going to tell you, or the directions are going to tell you, or it's going to say it in the problem. So for example, and I'm going to write it up here, it might say, and let me just clear that, it might say A plus 1 if A equals 5. All right? So here's my question real quick, guys. What number is A waiting on? What number is A waiting on? Jack? What number is A waiting on, Morelli? Maribel? 5. Guys, right here. Do y'all see right here? A equals 5. So the number that's going to replace A is 5. So this becomes 5 plus 1. Now, here's my question. What's 5 plus 1? 6. Guys, y'all just did algebra. All right? Hey, this is what we're going to do for like the first 2 weeks, basically, okay? Now, there's going to be a little bit more involved. Keep your pink paper. We're on the front still, okay? There's going to be a little bit more involved. We're going to go over this some more tomorrow, okay? See that? Good. All right. So, guys, a variable, it's just a letter that's waiting around for a number. Now, guys, right here on this problem that we just did, I said A is 5. Now, does that mean from now on, every time you see an A, it's going to be 5? No, A could be any number. This is something that was asked last year, and I didn't think about this because, again, like y'all are 6th graders, y'all think differently than I do, for sure. Okay? One student asked me, sometimes you have letters right next to each other. All right? Guys, A could be 5. A could be 55. That would change my answer here to 56. Okay? That one letter can represent any number. If you have letters next to each other, I want to mention this real quick. like x, y, what does it mean if something's right beside each other? It's multiplication, guys. All this means is x times y. So we could say if x equals 3 and y equals 11. What does that mean? X, y. If x equals 3 and y equals 11, what does that mean, Javon?
3 times 11.
3 times 11. And what is 3 times 11?
30.
30. Okay. So, Tony.
So in the problem or
I'm sorry, Tony raised his hand. Yes.
in the problem or the sentence, it will just give you the x equals something.
In the problem or in the directions, it's going to tell you what your letters are. It's going to tell you what your variables are for now. All right, and we're going to talk about why on this next definition. All right, our next definition says an algebraic expression. Right now we're doing something called expressions. An expression is a combination of variables comma, numbers, and operations. A combination of variables, numbers, and operations. Right? Here's something really important with these. There is no equal. There is no equal sign. I guess I should have written. There is no equal sign. There is no equal sign. There is no equal sign when we're talking about an expression. If there was an equal sign, okay, I'm going to come over next to my microphone here. If there was an equal sign, it would be called an, listen for this, equation. If there was an equal, it would be an equation. Do you see how equal and equation go together? Okay. An expression for right now, guys, we're not worrying about equal signs. We'll worry about that in 2 weeks from now, okay? All right. Let's talk about the word evaluate. Let's go ahead. The rest of these definitions we're just going to knock out kind of quickly because we're going to talk about them more in the upcoming days. And to evaluate means to find the value of an algebraic. If I could spell right, that would be helpful. Algebraic expression by replacing variables with numbers. Well, guys, y'all already done that, haven't you? Didn't we just do 2 algebraic expressions? We just evaluated them. All evaluate means is you're going to take whatever that number is, plug it into that variable, let it take that spot, and work it out. That's all you're doing. Evaluate just means work it out. All right? When we're evaluating, we're finding the value of the expression. In 3 weeks, we're going to do something called solving. When we're solving, we're going to find the value of the variable. Right now, the value of the variable is going to be given to you. That number that the variable is, I'll tell you that, or the directions will. So we're just going to find out the expression's value. In a few weeks, you're going to have to find what x is, or what n is, or what a is. That's called solving, and we'll talk about that in a few weeks. Yes?
Isn't it whenever you solve, you do it like 6 times x would equal 12? You would have to find what x would be by looking at the answer.
Yes, but not just by looking at the answer. We're gonna get into that because there are going to be certain steps you have to show and work that you have to show with it. All right? And you'll learn, Sean, in here I'm super picky. Like, we never do anything in our head because I can't see what's happening there. You have to show it to me on paper so I know what's happening here is correct. Okay? And we'll talk about that when we get there. All right, let's talk about a term. Oh, hold on. Real quick, evaluate, and we did this a minute ago. I'm just going to write it out. X plus 5 if x equals 3. So that would be kind of an example. What would I do with that x equals 3? What am I going to do with that? Hunter?
5 times 3.
Not times. It says x plus 3. And then it tells me x is 3. So what does that mean my problem should say, Anahi? We're going to write under here 3 plus 5. And then underneath 3 plus 5, what does that equal, Truett? 8. And we would have to show all of those steps. Because, guys, if you're changing the x to a 3 in your head, can I see that happen? No. So you will have to write it on the paper, and then you can do your addition. So that's what I'm talking about. I can't see it in here, so you got to write it down for me. All right, term is a number. Can y'all still see where I'm at? Okay, let me know when I need to move it up. A number, a variable, or number with variables in, and I'm putting a parentheses around that S because it might just be a number with one variable, but it could be multiple, in an expression all right, and these are going to be separated by operations symbols. Separated by operation symbols. Okay. All right, like terms. Like terms, it kind of sounds like alike, but they shortened it to just like. Like terms are terms. I always think about it as terms that match, terms that are alike. But writing it out correctly, terms that contain the exact same variables or variable or variables to the same power. Now remember, power, that's like exponents. Because guys, y'all are going to see exponents with these. Alright? For them to match, they have to have the same letter and the same exponents. Does it say anything about the number in front matching? No, the number doesn't matter. What matters is your variables and your exponents have to match. Alright? And then the last word is constant. The last word is constant. A constant is a term without a variable. Is a term without a variable. Okay? So guys, I want us to think about something real quick. If I look at the definition for term. You'll see where I'm at? The definition for term right up here, number 5. If I took out the stuff about variables, if I took out the stuff with variables, what does it say? A term is a number or number. So when it says a term without a variable, what is it really saying? What is it? If it doesn't have a variable, if it's a term without a variable, what is it actually?
A number.
A number. That's all that's left is a number. Okay. So underneath that, let's just write that is called that it's a number by itself. All right. So guys, you'll notice like in math, there's always a reason things are called what they're called, all right? And I want to talk about the word constant and the word term for just a second. I'm sorry, the word constant and the word variable for just a second. All right? So guys, when it says constant, and we're saying it's a number. So like the number 1, can the number 1 ever mean anything besides 1? No, 1 is just a 1. Let's say on your test, I put 76, and you come back to me and you're like, Miss Sawyer, I only missed like 1. How did I get 76? Oh, that 76 really represents a 95. You're going to look at me like I'm crazy, right? Because a 76 is what? 76. A 95 is a 95. Can they change places? No. So a number is constant because it never changes. A variable, that letter that we're talking about. So on some problems we saw x was, I think on our notes we said x was 3. But earlier we had said x could be 5. X could be 11. Is x always going to be one number? No. X can change. X varies, which is why it's called a variable. Y. Y can be any number, right? Y varies, so it's called a variable. Yes? I post them on YouTube and I send them out on Remind. Remember that paper I gave you? That'll send them out. So like if you miss school, you don't have to miss math because sometimes it can be overwhelming coming back when you've missed a whole lesson. So that way you can do things if you're out, or if you get home and you realize, ooh, what was that? You can go back and watch the video. Find it in there. Fast forward. YouTube. It's just Kimberly Sawyer. It's not very creative. All right. All right, guys. Are there any questions about the definitions? Okay. You're going to see this on a test in 2 weeks. Make some flashcards. Start studying them now. All right, let's talk about today. Today, we're not going to do algebraic expressions. We're going to do numeric expressions. What does the word numeric make you think of? Numbers. Because here's the thing, guys. Before you can do math with letters, you've got to be able to do it with numbers. All right? Can someone remind me, when I'm working these types of problems out, what do I have to use in order to find that answer? Camilla? There's a certain order of steps called the order of operations. What helps me remember those steps? Truett? PEMDAS. Please excuse my dear Aunt Sally. All right? And remember, when I get to, and you look at how I wrote it, MD is next to each other because we go from left to right. AS is next to each other because we go from left to right in order. All right. So for number 1, what operation am I going to do first here? Hunter? On number 1, what are we doing first? What does the P stand for? What? Yeah, and what does P, what does please stand for? Jet? Parentheses. And Hunter, do I have parentheses here? Yeah, parentheses are these little marks right here. So that's where we're going to start. This is the first thing we're going to do. All right? Am I doing anything else here? No. So 15 minus 7 is 8. Everything else stays the same. 64 divided by stays the same. Times 2 minus 9 stays the same. All right, now what do I need to do? Camilla. All right, are there any exponents here, Camilla? No. Excellent, but we checked. We did our parentheses. We checked for exponents. Now what should I do? Siobhan? Dividing comes first. So even though it says multiply, divide, my dear, remember we do it, whatever comes first in the problem, division comes first here. So we're going to do that division. 64 divided by 8 is 8 times 2 minus 9. All right, now what am I going to do? What's next? Hunter. Now we're going to multiply. 8 times 2 is 16 minus 9. And then 16 minus 9, Akenna? 7. And you see how I underline each time what step I'm doing. All right, number 2. Now number 2 is a little bit longer, so we're going to try to squeeze that in right there. Number 2, what do I have to do first? What do I have to do first? Hunter? Parentheses. But if I look inside these parentheses, do y'all see I have an exponent? Yes. And I have division? Which one of those am I going to do first? Akenna? The exponent. Guys, that says 4 to the third. Can anyone remind me, what does 4 to the third actually mean? 4 to the third. Hunter? Javon? 4 times 4 times 4 3 times. We're multiplying 4 3 times. Okay, am I multiplying 4 times 3? No, they would write a multiplication if that was it. It's 4 times 4 times 4. Okay, so 4 times 4 is 16. And then I might need to go to the side. What does 16 times 4 give me? 64. Awesome job, Anahi. So I get 64. Have I done anything with the parentheses yet? Am I done with that? No, that's still there because I still got to do the division. So there's my divided by 2. I'm bringing everything else down. All right, so now this is my new problem. What's going to be next? Following my order over here on the side that y'all can't see anymore. Trip? I'm still doing the parentheses. Inside the parentheses it says to divide. So that gives me, I'm going to start writing a little small here, 13 plus 64 divided by 2. Kaylin? 32 times 5 minus 17. Okay. Now what do I need to do? Now what do I need to do? Jet? The multiplication, 32 times 5. All right, so I get 13 plus 32 times 5 is? 32 times 5. Times 5. What was that, Anahi? 160. And guys, you need to go to the side and actually do that multiplication, all right? Now, what's next? What's next? Kelsey. Addition, because it comes first. 13 plus 160 is 173 minus 17. And 173 minus 17. What do I get for that? 173 minus 17. Trip? 156. How would I work that out? Guys, go over to the side. Line it up and subtract, okay? Go over to the side. Line it up and subtract. You'd have to borrow the 3 borrows from the 7, making it a 6. 3 becomes 13. All right. We have one more problem, and I should have numbered it number 3, so I'm going to put it right now. Number 3 is this art problem. All right. It says an art supply store sells posters for $9 each. Picture frames for $15 each. So the frames are 15, the posters are 9. Write an expression for the total cost of 6 posters and 6 frames. So we're going to, am I just finding the answer? No. We have to write out a math problem that's going to let me do all that work. All right, so what do I need to do for my expression? If I need to know the cost of 6 posters and 6 frames. Let's just start with 6 posters. How would I find out how much 6 posters cost? 6 posters. Hunter? Multiply what?
9 times 6, and you get 54.
All right, so pause there. So just for the 6 posters, it's $9 for each of them, right? So we're going to do 9 times 6. Now, is that the only thing we're doing? No, it's not asking you to work it out. You're not supposed to work it out right now. And 6 frames. So how would I find the cost for 6 frames? Akenna?
15 times 6.
They're $15 each. So I do 15 times 6. Now, guys, this is the cost for the posters. This is the cost for the frames. What am I going to end up doing with those? Kaylin? Adding. So in between that, we need an addition sign. Okay? And if you wanted to specify and say this goes together and this goes together, you could. But here's my question, guys. Doesn't multiplication come before addition anyways? So wouldn't those go together first anyways? Okay. All right, now we want to find the total cost for 6. Guys, pay attention to this. It says framed posters. Does it just say 6 posters? No, it also wants them framed, which would be my 6 posters and 6 frames, all right? So we've actually already set it up. So let's do our 9 times 6, which gives me 54, plus 15 times 6. What was that, Anahi? 90. You're on a roll today. All right, and now we just got to add that together. Truett? 144. So that's going to be dollars because that's the cost, right? $144 for 6 framed posters. And that would be my sentence to go with my word problem, because if there are words, we need a sentence. Guys, your homework is on the back. Okay, I want us to get to work on that. Homework is on the back. Let's see if you can get the first 5 knocked out. Let's see if we can get the first 5 done.